that we're working with here. Too many things open. Okay, so there's that function. We could stretch this out again so we can have a look at it here. Oops, we need this. Okay, the average rate of change we talked about before is the secant line. A secant line is a line between 2 points. What did I say on there? The interval between 1 and 3 or something? So we need that to be on 1. Even more. So this is, there's 1, or there's 3, and here's 1. Okay, so you're looking for an average. That slope is the average change. If you started at 0 and you ended at 24, and it happened over 2 here, the change is 24 over 2, right, or 12. The average change from there to there is 12 units per 1. You can use this kind of notation like you had from grade 10, or this delta y over delta x. If this function is called f of x, you can use f of 3 minus f of 1 over 3 minus 1. In other words, here we had what? 24 minus 0 over 3 minus 1. Or 12, right? The average rate of change is 12. That's the slope between 2 points. It's also called the slope of a secant line. Secant line is between 2 points. We want to compare that to how that's related to the slope of the tangent line. Yep. Okay. Hold on to the question for a minute here. Sorry, what? It's related, I think, if you draw a picture of triangle and all the angles and everything, they are related, but don't ask me to do that right now off the top of my head. Tangent to a curve. We talked about this being the instantaneous rate of change. At the beginning of this unit. At A. So we're going to do, this is saying we're defining the rate at which the value of the function is changing at a particular x value at that moment. So this is comparing, if you're driving in your car, the average rate of change is you looking and saying, okay, I just drove for 2 hours and I went 180 kilometers. And so figuring out and saying, well, I started at 0 and I ended up at 180 kilometers. And I did that in 2 hours, right? 90 kilometers per hour. That's an average rate of change. This one down here, this tangent line, is what's happening at a given moment. This is the speed on your speedometer at any given moment. The instantaneous rate of change. It's not your average speed. It's the instantaneous speed. What's happening at any given moment. If we have some kind of function here, and I guess we're talking about, this is a here, some value, some x value, and if we want to know I guess let's make it steeper so it's easier to see here. If we want to know and we have talked about this before, but if we want to know the actual tangent there, the actual slope at that point, the way we're going to do that is by looking at the slope of the secant and pushing the points closer and closer together. Before we called this something plus h, where the distance in between was called h. Not sure if you remember that or not. Okay, that's h. And then we have f of a plus h and f of a. So back to this picture here. We are going to, if we want to know the slope at this point, at 2, we're going to do this by putting this green point on there and then slowly pushing this one closer together, because more closely you push them together, the more the green line approaches the red line, right? If they're far apart, on this side it's too high, on the other side it's too low. If you get it, the closer you get it, the more closely they are to each other. If you take the limit, they're going to be equal. The limit of the slope of this secant line is the slope of the tangent line. The limit is if you push them, if you can take the limit of that. So what we are going to do here is write an expression for the limit of slope of secant equals slope of tangent. So the way we wrote this is the slope of the secant was what? How do we write that? F of a plus h minus f of a, right? Whatever a happens to be, like whatever value. If you want the value, like in this situation I was just showing you, if you want the slope of the red line at 2, that's what a is. A is 2.
Does it use something that means the opposite of the limit of the slope of tangent? Like something that felt like it was longer.
Ask me in a second here once we finish this thought here. An inverse you're talking about of limit?
Well, not exactly, but something like that.
Not necessarily. If you want the limit as what are we going to put down here? What limit are we going to take? This is the slope of the secant. It's when the points are separate. If we want the points to become the same point, we have to look at the limit as what happens. H goes to 0, right? H is the distance in between them, right? H is a plus h minus a, right? Look, we'll do a specific example under here. This is the slope of the tangent. Slope of tangent at x equals a, right? That's the slope of that at a.